Assalamualaikum and good morning to the examiners. My name is Wan Farah Amira binti Wan Ismail and my metric number is S47321. Okay, my supervisor is Dr. Auni Asla bin Mat Daud. Okay, today I'm looking forward to talk to you about my research. My research is about mathematical modeling and analysis of smoking. Okay, as you can see, my talk this morning is divided into 5 sections. Okay, first of all, introduction. Second is literature review. Third is methodology, which is contain a few parts of such as mathematical modeling, local stability analysis, Jacobian matrix, and Rutherford criteria. Okay, next is results and discussions, which is contain mathematical modeling, stability analysis, and characteristic of polynomial. Okay, finally, of course, we will talk about conclusions and recommendation. Smoking is a global poisonous among young people. It also gives the economic problem, health, and nation's public. Okay, furthermore, research shows that the youngest smokers become adult smoker and become their traditions in their family. There are 3 main objectives that we want to achieve in the studies, where the mathematical modeling has a significant role to explain in explanation how smoking population dynamics are. Okay, first of all, to construct a mathematical model of smoking in a population. A second one, to find the equilibrium points for the developed mathematical modeling. And the last one, to conduct the local stability analysis of the equilibrium point. For this chapter, we will like to analyze the mathematical modeling of population dynamics and perform an overview of local stability on every point of equilibrium that we reach. I want to describe 2 ODEs that can be formulated with reference to the above flow diagram, which is important to illustrate the subpopulation and also the movement of people between the subpopulation. I would like to introduce to you the stability of analysis. Okay, there are 7 steps of stability analysis. Okay, first of all, we will find the equilibrium points by equating all to the 0. And the second step, we will determine whether they are biologically meaningful. Okay, and the third step, which is we need to find the general Jacobian matrix and then calculate. Okay, for the next step, we will substitute all the equilibrium points that we get into the general Jacobian matrix methods. Okay, next, we also need to find the determinant of Jacobian matrix, which is determinant J minus lambda I equal to 0. Okay, next we will determine the types of stability. Okay, for the last steps, we need to repeat all the steps until all the equilibrium points obtained in step 1. In this chapter, we will create a model to define a smoking population dynamics that use a flow diagram, just like a previous chapter. Okay, we use ordinary differential equation system. Okay, this 4.1 figure shows that the movement between one population to another subpopulation. Okay. I will explain to you all the subpopulation. Okay, first of all, P is represent the number of people in each population. Okay, which is non-smokers. S is represent the number of non-cancer smokers without having a cancer. Okay, the last one is Q, which is represent the number of currently smokers with cancer due to smoking. The general Jacobian matrix form that obtained, we will insert the value of 2 equilibrium points, which is input the values of P1, S1, Q1, as P2, S2, and Q2 into matrix form to get a new values. There are a few things that I can conclude, which is to investigate mathematical models of the smoking population's dynamics. Okay, it's also smoking population dynamics is using a flow diagram, which is then changed from ordinary differential equations into non-linear system. Okay, from what we get from this research, there are two equilibrium points in the models. The outcomes of the local stability analysis shows that if the Roth-Hurwitz criteria are fulfilled, the two equilibrium points are locally asymptotically stable.